So welcome to line tracing, also known as raycasting. In this video, I'm going to explain that line tracing, also known as raycasting, is a very useful tool in game development, used for all sorts of things, from laser tripwires to predicting the paths of bullets to what we're going to use it for, which is reaching out and working out what we can grab and pick up. So imagine we shine a virtual laser into the world. That's the essence of what we're doing here, and we've got the ability to interrogate what's actually been hit. We can use different view modes in the engine to visualize what we would actually end up intercepting with, and that's really cool, and you'll see that in a moment. And we will be simply simulating physics on objects that we want a bit of lift. And by setting simulate physics, we are going to be setting the object channel, which is what the raycast is going to use to ignore things like floors, walls, and doors, and to focus on the things that we want a bit of lift, like tables, chairs, and the like. So let's dive in and see how it works. By the end of the video, you'll be doing things like visualizing your world from a collision viewpoint like this, and you'll also read a very helpful blog post from Unreal that will help you understand this stuff. So this debug trace we've drawn is just to help us visualize what's going on, but the system is not actually doing a line trace or raycast yet. That's a completely different thing. By the way, this debug trace will still exist if you hit launch rather than play. What hitting launch will do is actually make a version for your platform, your Mac, your PC, and it'll make an executable. It is a good idea to actually build and run the game properly like this. This is an actual PC app now, a 64-bit PC app. And you'll see we've still got this debug trace there. We've also got some warnings about the lighting because we didn't rebuild the lighting. So it does stay there even when you're not inside the editor. But it isn't actually, by the way, to get out, it's Alt F4 on the PC or Command W on a Mac. But it isn't actually a raycast. We can't actually query to say what it's hitting. It's not intercepting anything, etc. So what we need to do is think about how we're actually going to line trace in the world. Before I show you lots of cool things, I want you to just do something, which is to go and read Unreal's blog post here about collision filtering. And I want you to, when you read it, realize that the same rules apply to the line tracing that we're going to be doing, and share your understanding of collision filtering in the discussions for us. I'll just click the blog so you can see you're going to the right place. When you arrive, it should look something like this. My broadband's on the go slow this evening. There you go. That's what you're looking for. So go ahead, pause the video, take a quick read of this now. Cool, welcome back. So this world here, on the left-hand side, you're seeing the visibility geometry, the visible geometry of the world, all the complex geometry. On the right, you've got a very simplified version, which is used for collision and for line tracing in the world. Now, back in Unreal, look at this. We can actually do this. What we can do is we can click on the top left of our 3D viewport where it says lit, and click on there, and you get a load of view modes. One of those is player collision. That immediately shows us a couple of problems. The light cyan stuff here is static meshes. Now the chair, of course, should be movable. So if you click on the chair, click on details, and go over to movable there under the transform, we've now made the chair movable because we want it to be movable. The other problem that it shows up is that the doors are not collidable with. And actually, if I play my game in normal lit view, I can pass straight through the doors right now. There you go. So, why can I pass through the doors? Well, this is actually a version control problem. Do you remember that we used to ignore the starter content? And if you look at a door and right-click and go Edit SM Door, my door doesn't have its collision mesh on it anymore. So make sure your door does. If it doesn't, add another box collider on and save. And when you save that, you'll notice from the source control, if we look at what's different right now, just wait a second, here you go, that there's a door asset file here. There's the only thing I've changed in this video, and it's stored in the starter content folder. We used to ignore the starter content. So what happened is we lost those changes. We lost track of those changes. If at this stage you think, well, actually, what are we tracking and what aren't we tracking in source control, then just go ahead and take a look at your all the way back here at your .gitignore and remind yourself what you're ignoring. We're happy ignoring these folders. We talked about those earlier. We are still ignoring textures and HDRI. They're the only things that we're ignoring in the starter content. So still, if you change anything in these folders, any of your textures or HDRI stuff, it will get forgotten, but everything else will be remembered now. So always keep in touch with what you're ignoring. We're ignoring those things, of course, because they're huge, remember? Okay, so here we are. We've read that blog. We have got some idea that this world has visibility that can be looked at two ways. You can either look at it from a collision point of view, which is showing us the trigger volume here, the static meshes here, and now the dynamic things, which are both the door and the chair. Or you can look at things from a visibility collision viewpoint. Now, if you click on that, you're now seeing the only thing that really changes in detail is the chair. It goes from a very blocky collider volume like that to that. Now, we can actually decide when we line trace in the world whether we want to take notice of all these details of this geometry or not. And in our case, we don't. It's fine to just say that the little red line that we're going to have from our pawn is intersecting anywhere in this collision geometry. That's good enough as a line trace hit. So this is a cool view, and it allows us to see the world from the viewpoint of how the collisions and the line traces are going to work. The question comes, if I bring a new item into the world, so I go to Content Browser, I didn't mean to close that tab, by the way, I just clicked the wrong thing, and Props, and say I bring in a table like this and drop it in, and it quite nicely defaults to the floor, there it is. Now, it looks really funny in this view, of course, but if I go back to the standard view, for which there is a shortcut, it's Alt-4, let me do that, Alt-4, then the table's there, it's sitting on the floor, but from a collision point of view, at the moment, this is just a static piece of scenery. And what I want to be able to do is to make the life as easy as possible for us when we come to rapid level building, so that we can very quickly, ideally in a single click, tell the system that this chair isn't just scenery and that it's movable. And the very most meaningful way to do that is to click on the table, rather, come down to under Physics, and you just click Simulate Physics. And immediately below that, it's asking for the mass in kilograms. You could say 15 kilos, for example. By doing that, a few things change. It becomes movable, which makes sense if it's physics objects. But also under collision here, we have collision presets, and it's set it to physics actor. And the object type has actually changed, but there's a little bit of a bug in the editor, which means we have to click off the object and back on it to get to see what the new object type is. So the object type becomes physics body. Okay, so from the article you read, it talked about two types of filtering. One was filtering by the type of line trace, which we're not doing here, and the other is sorting by the type of object. And we're going to do that. We're going to filter by the type of object. We're going to say that the types of things we can pick up are any physics objects, physics body object types. So you click on the door, it's not, it's a world static, and the walls are world static, and the floor is world static, and the trigger volume has some sort of collision type. What is it? It's world dynamic. But the only things that have the collision type physics body are the chair and the table. Now, why doesn't the chair have that correct type? Because we haven't yet simulated physics on the chair. We click Simulate Physics, give it a sensible mass immediately, and that's all you're going to have to change. Super simple for the designer. And we could even give ourselves a limit to how heavy a thing we can lift. So, for example, we could come in and we could stick a light on the wall, right? There it is. Let me just see it in Alt-4. In this view, move the light up a little bit. Now, I can decide, do I want that to be movable or not? If I don't, I just leave it as it is, and that is a piece of scenery. If I wanted a bit to move the light, I could set physics on it and set a mass. Now, in this view, things that are cyan are just static and we cannot lift. Things that are purple here, magenta rather, are dynamic objects, but we also can't lift them. We can only lift the green things, which are the physics objects. Also, we have a green thing here, which is a completely different type of thing. A trigger volume just happens to use the same color, but it associates visually quite nicely. These are the things that we could lift and put down over here. So I really like it. It's a really simple way of doing it. So we're going to use object channel filtering, and all we need to do to tag an object to be something that we want to be able to grab, as I said, is to just simulate physics, and while you're there, give it a mass. That will in turn set the object type to physics body, provided you click on and off again to fix the editor bug, and it's that physics body object type that we're going to use to filter. That's one of many object types that we can set under project settings, collision, and then object channels. We've got a bunch of default object channels. You can add more object channels here, but that just gives you more work to do. Why not take advantage of the fact that when you simulate physics, you automatically become a physics actor that automatically has a physics body object type. Okay, by the way, all these presets are also accessible under project settings, collision. If you really care, you can go to preset and you can see all of these here. Well, not all of them, only the ones that are exposed. And actually, the physics actor is not one of those that is exposed. So we don't need to worry about that. We just need to know that by putting physics on, we are making the thing respond to the physics engine, number one, which is fun. So if I bang into things, not going to work with the pawn, but later on they'll move. Number 2, they have a mass which you could use later to determine a limit to how much we can lift. And number 3, they set a collision preset that means we have a physics body which we can use for filtering so that we don't try and lift walls, floors, ceilings or doors. So that's that. I'll see you in the next video when we'll actually start doing some line tracing.